Hi, I'm Jennifer Bergman with Khan Academy, and today we're going to be looking at what makes a cloud. Now, a cloud is something that you might see in the sky almost every day around your house. It's certainly something that you could spend a lifetime studying if you chose to do a degree in meteorology, or you chose to do your thesis, a PhD thesis in cloud physics. But when you boil it down to the basics, a cloud is actually made of 3 ingredients. The first one is probably the most familiar to us, and that's water. So most of us have studied the water cycle in school at some point. We know water is found in clouds, and in clouds it's found in the liquid form. So I'm going to actually be making a cloud in a bottle here. This is a 2-liter soda pop bottle, and I'm going to pour our first ingredient in. So if you want to follow along and do this at home, you're going to want to pour about 1/3 or even a 1/4 cup of water into your 2-liter bottle, just as long as it covers the bottom of the bottle. Now our second ingredient is something that scientists use. It's a fancy word, they call it cloud condensation nuclei. And it's often actually abbreviated CCN. You can see why. When I finish writing this, you have a C here for cloud, that's what we're making with our water. The condensation refers to the process that's happening, we'll get to that in a second. And nuclei, meaning it's at the middle of our cloud particle. So if you think of a cloud water droplet here, and there is a particle at the middle, that's called our CCN, our cloud condensation nucleus. And these particles that are actually found at the middle of these water droplets can be almost anything that you can think of. So it could be dust that's kicked up in the desert, it could be dirt that's kicked up on your driveway, it could be ash from a volcano, it could even be pet dander that's released when your dog is running through your backyard outside. It can even be, CCNs can be tiny pieces of human skin, which is kind of neat to think that you could be actually part of a cloud. But the most common cloud condensation nuclei is actually sea salt, and I'll explain that here. I'm going to go ahead and draw a globe here, a picture of the Earth. And a globe is obviously, or the Earth is covered with 2/3 water and about 1/3 of land. So you think about it, the globe or the Earth is actually covered with a whole lot of water, and that ocean water is being kicked up into the air all the time by waves and winds, and that actually releases a little bit of sea salt into the atmosphere. And because the Earth is so much covered with water, it's the water planet, that's why we have our most common cloud condensation nuclei, these CCNs, being sea salt. Now, if you think of this in everyday terms, you actually can see these cloud condensation nuclei on your car after a rainstorm. So you might come out after a rainstorm and think, oh, wonderful, my car, my SUV is going to be totally clean, it's just been washed off by the rain. But in reality, you come out and it's covered with little pieces of dust or little pieces of dirt. And that's actually these particles that are left over from the rainstorm. Each of those water droplets that fell, or each of those snowflakes that fell onto your car, left a cloud condensation nucleus on your car. And so you do often have to get a car wash after it rains. So in our demonstration here, I'm going to use the cloud condensation nucleus of smoke. So I'm going to go ahead and light a match here and drop that into my 2-liter bottle. And I'm just going to cover it, and that will actually give me my cloud condensation nucleus, or those particles that my cloud needs to be able to form. So on the end of here, I did cap this with a gizmo here I called my pressure gizmo, and that leads us actually to the third ingredient. Now, if you have some minions at home, here I have my 2 kids, I'm actually going to have them help me in my next ingredient. So my next ingredient here is actually a drop of pressure. And so you can see my minions here. They are actually pumping this pressure gizmo on my 2-liter bottle. So I'm going to draw a 2-liter bottle here. And we can say that 2-liter bottle had a certain number of particles in it to begin with. Say it had that many particles. Each time they pump this gizmo, and this is often advertised in your soda pop aisle because it's a gizmo that if you pump increases the atmospheric pressure in the bottle. It helps to let your soda stay fresh and not get flat. It helps your seltzer water to stay fresh. So each time you're pumping this up and down, you're actually bringing in more particles from the air each time you pump it, and you're increasing the atmospheric pressure each time. And you can feel this at home. As you're pumping it, it will A, get harder to pump, and B, the bottle will actually get firmer, so you know that this pressure is increasing, or you know that the number of particles in this given volume that's not changing is increasing. Now, the way that I'm actually going to create my cloud is I need my water, which I have, that was ingredient number 1. I need my cloud condensation nuclei, and in our case that's smoke from my match going out. And I need a drop of pressure. Now I've increased the pressure, or more accurately, my minions have increased the pressure, and now I'm going to release that pressure so that you have a lowering of pressure, or a drop of pressure, which is the 3rd ingredient. So if you'll see, I'm going to release our pressure gizmo, and a cloud is formed. Now in everyday life, if you think about this, that lowering of pressure you often see on different weather forecasts. Maybe on a different TV station that you're watching, you see that big blue L come across on your weather map, maybe if you're looking online. That lowering of pressure, that drop of pressure, is often associated with cloudiness, that low pressure system, or it can be related also to precipitation. But those basic ingredients, the water, the cloud condensation nuclei, or what scientists often refer to as cloud seeds, and that drop in pressure is what we needed to make a cloud. So I hope you'll stay with us and learn more as you look at different sections of the site. We do have videos on the water cycle. We have videos on states of matter, including that process of condensation that we talked about in our liquid water droplets. We have different videos on reading a weather map, and even videos on types of clouds. Enjoy.